This is our last section in chapter 2. I would like to point out the fact that on Thursday, we are going to have a test. Okay, so I know that it says on Wednesday, but I pushed it to Thursday. I thought you would appreciate that. Okay. An absolute value inequality. That's what we are going to be working with today. So an inequality that contains an absolute value.
It's my afternoon.
Connor, that's enough.
Miss Holman, I have a complaint.
I don't want to hear it right now. Put your finger down. Okay, so this is what's going to happen. Well, first of all, somebody tell me, don't write this down. If we had the absolute value of x plus 3 equals 7, and we wanted to solve it, raise your hand. What would we do, Henry? That is not what we would do. Okay.
Set up x plus 3 equals 7 and x plus 3 equals -7. We all messed up that one.
I said don't, okay. Now, when we have an absolute value inequality, okay, it's the exact same thing. We're going to have two inequalities, right? Now, when we have two inequalities, those are called compound inequalities. And there's either going to be an or an and in between the two inequalities. Okay, so I am going to point this out right here. We're going to rewrite it down below so we can talk through it. Okay, basically, if we have, well, maybe we'll go off to the side, the absolute value of ax plus b is less than c, then what we're going to do is we are going to split this up into two inequalities. I would. We're going to have ax plus b is less than c. We're going to have ax plus b. We're going to switch and switch. Okay, so we're flipping the inequality sign and we're flipping the sign of c. Do you see how both of them changed? Okay. Yes, Brooks. Thank you for your commentary. When we have the less than, our compound inequality is going to be and. No. When the inequality for our absolute value is less than, we get an and. However, Henry? Switch. Yep. If we have the absolute value of ax plus b is greater than c, then it becomes a compound inequality. Ax plus b is greater than c. Ax plus b flip, but in between, we're gonna have or. Greater than. So when you were gone, we talked about when we solved absolute value equations, we created two equations. One with the positive, one with the negative. So we're doing the same thing here. The only thing though, is now that we have an inequality sign, we're gonna have a compound inequality. So our compound inequalities are either and or. Well, if this starts out as an absolute value that is less than, our compound inequality is and. But if this is absolute value that is greater than, it's gonna be an or. Do you see my emphasis on great or?
Toronto?
If it's about getting a drink, don't even ask it. Right now, we're gonna focus on that. I'm so sorry. When you get this, can you please fold it once to make it look like a book? Where example one is on the front page. Okay, nothing that I have said is anything that you should be making noise for. Example one is the front. So fold it into a book. So example one is on the front. Look, sit down. Byron, sit down. Okay. Okay, so our first example is the absolute value of x is less than or equal to 12. Okay. So first of all, our first step, it says to rearrange the inequality. So the absolute value bars are on one side and everything else is on the other side. Is the absolute value bars by itself?
Nope.
Okay, already done. We have the absolute value of x is less than or equal to 12. Okay, so now what we're gonna do is we're gonna break this up into two inequalities. We're gonna remove the absolute value and keep the inequality as is, just with no absolute value. For the second inequality, we are going to switch the sign. So notice how the inequality sign and the positive negative sign switch. Okay. Now, is this an and or an or statement, Kyron?
It's an or. Wait, no, it's an and.
Great or less than.
Yeah.
Noah. So now we need to solve the compound inequality. Guys, is X already solved for? Yeah.
Yeah.
So we have, so you can leave it as X is less than or equal to 12 and X is greater than or equal to negative 12. But we also know that with our and compound inequalities, we can make a sandwich. That's not funny. It's fine. You wouldn't have to. I'm just saying that you can. If you leave it like this, it's fine. Okay. Yes, we'll come back to our student journal. Okay. Now, Harry, pick a number in this interval.
Negative.
Can you pick a number between negative 12 and 12, please?
Negative 12.
Okay.
It's 0.
If I plug in negative 12, is it going to satisfy this inequality? So when we graph our solution, what's our graph going to look like? Sorry, Henry. Sorry, I was looking over Harry's. What did you say? Oh. I apologize, Henry. I was looking over Harry's head to Henry. And it very much sound the same.
I've never heard
You know what? It's been a really long day for a really long week. You can just. Okay, example 2. Open up to example 2. No way.
R says X is of the value of X is less than or minus 1 is greater than 5. Yours
Okay.
just says
Now it does. All right. Whoops. I must have added that in after the fact. Okay. So here's the deal. Is the absolute value of X by itself? No. Reese, what do we need to do to both sides? We need to add 1. If we add 1 to both sides, we get the absolute value of X is greater than 6. Okay. So our 2 inequalities, Noah, we're going to take the absolute value off. X is greater than 6. Then we're going to write X is flip the sign, flip the sign.
less than negative 6.
Okay. And we decided this was and or. Great or. This is an or statement. Okay. So we have X is greater than 6 or X is less than negative 6. Okay. So we have an open circle at 6, shaded to the right, and an open circle at negative 6, shaded to the left. Wait, what? Does anybody have a wait what question about the math? Or is this like conversation that has nothing to do with this example?
Probably that.
Well, I kind of zoned out for a second.
I never done that. I was on that.
Harry, that's very unlikely to go now.
You want to hear it again?
I think it's just time for me to go.
You don't want me and Harry can just laugh.
Okay. All right. Next one, example 3.
Get the boys.
Okay. Kyron, are the absolute value bars by itself?
Oh, yes.
Yes, they are. Okay. So our first step, we actually don't have to do any moving around. Okay. Now for our two inequalities, remember we're going to remove the absolute values and just keep it x plus 5 is less than 9. Then we're going to flip or switch and switch. So both of these change signs. Okay. This is less than. Oh, you got the hint. Okay. Is that helpful?
Very helpful.
I mean, no, we did.
That's quite useful.
Okay. Now, are we done solving? No. We need to take x plus 5 is less than 9, and we need to move the 5 over to get x is less than 4. And we have x plus 5 is greater than -9. We need to minus the 5 over to get x is greater than -14. Okay, I am totally fine if you leave your answer like this with the and written in between, but it is also possible to say x is less than 4 and greater than -14 and make it into a sandwich. I don't care how you express your answer, but you gotta have the and in there. Do you understand?
Yeah.
Okay. Okay, so we have greater than -14, but less than 4. So here is what our graph would look like. Please stop.
We do Josh.
I found
You call him Josh? No, you do Josh.
Okay, let's go ahead and go to number 4.
I feel like I'm watching.
Oh, wait.
All right.
Okay, we are going to do number 4 together, and then in your student journal, I'm gonna give you one to do without me, okay? So just be quiet. Okay, so my first question is the absolute value by itself?
No.
No, in order to get the absolute value by itself, Connor, what do we need to do to both sides? We need to divide by 2. So the absolute value of -6x is greater than or equal to 30. Okay, DJ, are you following along? You're writing this down? Okay. We divided both sides by 2. So now we can make our two inequalities. -6x is greater than or equal to 30. Remember, we just remove those absolute value bars and keep everything else the same for inequality 1. And then inequality 2, we need to flip and flip. Flippity flip. Okay, please vote. One finger for and, 2 fingers for or. 1 for and, 2 for or. What does 3 mean? Okay. This is a great or then. Okay. This is great or then. So we're going to have an or statement. So now we have negative 6x is greater than or equal to 30, or negative 6x is less than or equal to negative 30. Okay. Now let's be careful, because what do we need to do to both sides of our inequality? Okay, we need to divide by a negative, which means this becomes x is less than or equal to negative 5, or x is greater than or equal to positive 5. Nope.
What do you think?
We keep it as or. I would like you to turn to page 56, and you and your elbow partner are going to do number 3. Number 3, lock it in. That's what I heard.
I walked in.
Just number 3.
What do you think?
Harrison Paul.
Nobody's known my middle name until now. It's Paul. It's Holman. Nobody's known it until now. Never mind. We're going over it, right? Hertz per second. Hertz per second. Game.
You haven't even done number 2.
You didn't either.
Alex, you did number 1.
I did number 1.
Number 3. Probably can.
Wait.
No.
Yeah, pull up his in.
I did not know.
You're really ask for that. You asked for that.
Okay, make 5. Make 5. Okay. Kari, what do we have to do first? Okay, we subtract 10, so we have 3. Absolute value of 2a plus 5 is less than or equal to 27. Allison, what do we do next? And if we divide by 3, we have the absolute value of 2a plus 5 is less than or equal to 9. Okay, so this becomes 2a plus 5 is less than or equal to 9. Carly, and or 2a plus 5 is greater than or equal to -9. So when we solve this one, Izzy, what do we get? A is what? A is less than or equal to. Because it'd be 2a is less than or equal to 4. So 2. And A is, Gabe, when we solve this one.
Can you spell that one?
Didn't you already?
Oh, yeah. It is greater than or equal to -7.
-7. Okay, you can leave it like this, or you can write A is less than or equal to 2 and greater than or equal to -7. Okay, I have a question. Are we done?
Oh, ma'am.
Why do I have people like getting into their backpacks, talking to their neighbors? Brooks, I don't need your help. If I did, I'd ask for it. You have book homework for the weekend. So what I'm gonna do, I'm gonna show it up here. It looks like it's 3 through 19 all for your homework, right? So I'm gonna have you start, and everybody's gonna do number 3, okay? Awesome, thanks. Everyone's gonna do number 3. It's gonna be difficult. Yes, you grab it. What?